Hi, and today we start Chapter 6, and Chapter 6, if you want to go on page 354, is on solving and graphing linear inequalities. And the first section we're going to start with, 6.1. 6.1 is solving inequalities using addition and subtraction. And I'll just write that up here. Solving inequalities using addition and subtraction. And the first thing we're going to start with, it'd be nice if I spelled subtraction correctly. There we go. Okay. The first thing we want to start with is, what does it mean to graph an inequality? If you look at the top of page 356, you will see that they highlighted the phrase graph an inequality. And I know sometimes that's always a sore spot. Some of us don't like graphing, okay? And I get that. When I was your age, I can't say I necessarily liked it either. However, when I started to understand why we graph, it actually made sense as to how actually graphing is a time saver. Let's take, for example, think about if I said x is less than 3, and I said, okay, the assignment tonight is to go home, and I want you to list all the values of x that would be less than 3. I think you'd soon realize that that assignment would never get done. You can list infinitely many values for x less than 3. That's exactly why we graph. The graph is a quick way to show all the values less than 3 because it is physically impossible for you to write them all down. So to graph x is less than 3, we would use graph paper. I would go to the point 3. Now I want all the values less than 3. So since we use less than, we use an open circle. An open circle represents less than. I misspoke. Represents not equal. Okay, let me say it again. An open circle represents that this can't equal 3. It's only less than 3. Okay, so this open circle means this is kind of like a fence. It's dividing or separating the points that are less than 3 from those that are bigger than 3, but we're not including 3. Now I want the values less than 3, so I can just take my pencil, and it would be just fine to kind of draw a wavy line through this, put an arrow at the end of it, and this is showing all the points less than 3. That's how I could graph the inequality x less than 3. If we had equals, let me just pick another one. Let's say I wanted us to find x greater than or equal to -2. Again, if I asked you to go home and write down all the values greater than or equal to -2, you'd never get done. But we can graph it in a short few seconds. Now, because we have equals, I'm going to actually close circle at -2, okay? I'm close circling. Close circle means equals, okay? So when we do have equals, we want to close the circle. Here, there was no equal. We kept it open. I want all the values greater than -2, and so I would just do this, and that's showing that all these values, arrow at the end, this goes on forever, is greater than -2. So that's why we graph. I will give you this pre-made number line to make it easier for you, but that's why we graph. It's actually easier to show these answers by graphing than trying to list them all. Okay? The next thing, we got to talk about equivalent inequalities, and so now I'm on page 357, and you can see the term equivalent inequalities. Now, you've worked with equivalent equations before. Okay? And let me review what an equivalent equation is. Okay? Here would be a simple example of equivalent equations. Let's say I have 2x plus 5 equals 21. If you take away 5 from each side, as you've done many, many times this year, that's an inverse operation, take away 5, you would end up with 2x equals 16. This equation and this equation are equivalent. Equivalent means that whatever the solution to this equation is would be the same as that. Now, let's do one more. If I divide by 2, I would get x equals 8. All three of these equations are equivalent. So in other words, if I plug in an 8 here, I get a true statement. If I plug in an 8 here, 2 times 8 is 16, I get a true statement. And if I plug in an 8 here, 2 times 8 plus 5 equals 21, that's a true statement. All of these are equivalent equations. Okay? We're going to work with equivalent inequalities today. So it's the same idea. Okay? Each inequality would have the same solutions to it. So, and why would we need equivalent inequalities? They are going to ask us to solve inequalities today and then graph our solution. That's the second major thing you're going to be doing. And we're going to be solving these inequalities and finding equivalent inequalities by using, and you can see in the title of the section, we're going to use, I forgot to put addition up here, I'm sorry. We're going to be using addition and subtraction to create equivalent inequalities. So here would be a sample of that. Let's go to number 10 of the bookwork. And number 10 says x plus 4 is less than 5. I want to write an equivalent inequality. Now, treat this just like an equation. Treat it like a balance scale, even though it doesn't say equals, it says less than. Okay? I want to isolate x. I don't want plus 4 here. To get rid of plus 4, I should subtract 4 from each side. And when I do that, I would get x is less than 1. Now, these are both equivalent inequalities. Okay, so in other words, for example, 0 makes this a true statement. 0 is less than 1. Well, if I plug in 0 up here, 0 plus 4 is less than 5. It's still a true statement. If I use negative 10 is less than 1. If I plug negative 10 up here, negative 10 plus 4 is less than 5. These are equivalent inequalities. Okay, I now want to graph this. So if I go to my graph sheet, I want to graph x less than 1. So I can do that. I go to 1. I put an open circle because it does not equal 1. And I'm going to shade all the values that are less than 1. Put an arrow at the end. That's what we're doing on this today. You are going to solve inequalities and graph them. Okay? I can also just take a look, go up to number 3 through 5. I'm going to have you do those also. It says write and graph an inequality that describes a situation. The speed limit on a highway is 60 miles per hour. Okay, so let's think about that. The speed limit on a highway is 60. That means that the most I can travel is 60 miles per hour. So if I use S for speed, I have to be less than 60 or equal to 60. Now, the other thing, I guess technically speaking, I disagree with the book's answer. The book stops here. They just said that's correct. Well, let's think about if this is the case. According to this, you could travel negative 100 miles per hour on the highway, which doesn't make any sense either. Okay? The speed limit on the highway is 60. I guess I could say, if you see the signs, there's also normally a minimum speed. Like on I-75, they say the minimum legal speed's 45. So I would probably say something like, okay, the speed on the highway is in between 60 and 45. I can go 45 miles per hour. I can go up to 60. Now I just need to graph this. So let me change my scale. Instead of 1 unit at a time, I'm going to call this 10 miles per hour, 20, 30, 40, 50, 60, 70, and so on. My maximum speed is 60, and it equals 60. So I'm going to close circle at 60. My minimum speed's 45. So I'll put a closed circle at 45 so I can equal 45. And I can travel anything in between. So I'll just kind of draw my little loops there. I can do anything in between. So that would be a graph of that situation. So the main things we are doing today is we are going to graph inequalities and solve them. Maybe I'll just do one more solving an inequality just to make sure we got it down. let's take a look at number, let's say we had number 20. Number 20 says we are going to solve 2.1 greater than equal c minus 6.7. I want to write an equivalent inequality. I have to solve for c. Well, the way to get rid of minus 6.7 is to add 6.7 to each side. That means c, we keep our inequality symbol, 8.8. In other words, 8.8 is greater than equal c, or if I want to flip this whole thing over so I can have my variable on the left, I could write c, but remember, alligator eats 8.8. Okay, I want to graph that. I want to graph c less than equal 8.8, so I can go down to my number line here. I'll just write it down again. This is what I have to graph. Equal 8.8, so 8.8 would be about here. I'm going to close circle, and I want all the values that are less than or equal to 8.8. Put an arrow at the end. That would be the graph of that situation. Okay, so I think I've covered what I need to cover here. I don't think I need my video to go on any longer than this. We'll have time to get started on this in class tomorrow, and if we have other questions, we can address those at that time.